Okay, so this is like I guess a skeleton model or a theoretical model of stretching and moving parabolas. I'm not sure if you guys covered it at all. H deals with movements left and right. Have you guys ever seen that before? Do you want me to write a quick note on it? Maybe? Okay, maybe better. If H is negative, so H less than 0. And what I mean by H is I'm not going to go into the whole explanation of this, but if this sign here is a negative, H is less than 0, then it shifts. I should type it so it's clear. Shifts to the right. Okay? So in other words, it's the opposite of what you would think. If it's negative, if H is negative, it goes in a positive direction. If H is greater than 0, so in other words, that's a positive. So I'm going to put a little negative sign there, a little positive sign here. So in other words, H is positive. It shifts, yeah, exactly, to the left, okay? So this was this way, this way. That's just a quick note for you guys to remember, okay? K is the opposite. K is logical, it makes sense. If K is less than 0, so if K is negative, and what I mean by K is that positive sign and everything here, it shifts downwards. Okay? And what I mean by shift is I mean the vertex. This is called vertex form. Okay? So I'll clarify that in a second. If H is greater than 0, so in other words, sorry, if K is greater than 0, if it's positive, it shifts which way? Yep, pretty straightforward. Okay, shifts up. And finally, A has to do with stretching, but I feel like you guys look at me a little funny, so I'm going to try to clarify what I'm saying.
Okay. Oh, cool.
I'm getting better with this. Oh, no, no. Sometimes it goes slow. Okay, so what I mean by this is, actually what's really lucky is I can use these things. So here's our parabola, let's say, okay? So that's what our parabola looks like. If we're talking about a shift in K, I take the vertex. So if K is negative, so I'm just going to put negative K, that means it's moving downwards, okay? So in other words,
it doesn't stretch though, it just goes down.
Yeah, it has nothing to do with it stretching. Just the parabola's vertex goes downwards, okay? And if K is positive, so positive K, our parabola's vertex goes upwards. Okay? I'm trying not to stretch it. I know it looks like it's been stretched, but it goes upwards. Okay? So that's all I'm talking about. The vertex goes up or down, depending if K is positive or negative. I should make this note down here, the next part. Okay, so same idea. If H, let's put our parabola first. The reason I'm putting the parabola actually down here, I should clarify that too. Okay, this parabola here, this is x squared. That's y equals x squared. Y equals x squared always starts, the vertex is at the origin. Okay? Do you guys know the rule when you're drawing a parabola? You go over 1, up 1, over 2, up 4 for a normal one? That makes sense? Okay. So this is our normal parabola. Y equals x squared. And same with this one here. This is a y equals x squared. That was our original. When we got a k, so in other words, plus k, this thing went upwards. And when we had the exact same equation, y equals squared minus k, the parabola shifted downwards. So that's the idea there. This one here is a little different. We're going to have two parabolas. We'll do a left and a right. So I have another one, same idea. Okay, Again, this is our y equals x squared. Um, if h is negative, so this is where our vertex moves to the right. This is when you have, think of it as h being negative, and think of this as h being positive. This isn't quite the case. If you guys want, I can explain that all, but the idea is if you look at the equation like this, y equals x, and we have subtract some number, that's when we move to the right, and the equation looks like that. And when the equation looks like this, y equals x plus h. So when we have plus some number, we move to the left. So that's the idea of the vertex moving left and right. The reason it's backwards is it actually isn't that h is negative, h is positive. The reason it looks backwards is because our equation says y equals, I wrote it at the top, I'm just going to write it in black now, minus h squared plus k. So what that means is if I get the number positive 5, and they say I'm moving it 5 to the right, okay? They're saying I'm moving 5 to the right. When I substitute positive 5 in for just h, what will happen is I get y equals ax minus positive 5 squared plus k. It's because our formula has a negative there. So what ends up happening is we have x minus 5 squared plus k. So the h is actually a positive number, but when it goes into the equation, it looks negative. So that's why we say that it acts opposite of k. Okay? It actually does go to the right 5. It's just the number looks negative. Does that make sense?
Mm-hmm.
Yeah? Have you seen this before? Or a little? Okay. So that's phase shifts, those are called. So that's a phase shift left and right. This is a phase shift up and down. I'll go to another page that way. I have lots of room. Okay. Okay. Next thing we deal with is an A shift. So actually, what I'll do here is I'm going to show you exactly how you draw one of these. A parabola, if we have this equation here, y equals x squared, you start at the vertex, and which is at the origin, 0 and 0. And you go left and right. So say I go over 1. Whatever I go over by, to figure out how much I have to go up by, I square that number. So because I went over 1, so again I go over 1, 1 squared is 1. So I just go up 1. There's my next point. Same idea. I go back 1, so I go negative 1. That's because I used that. Do you guys want me to keep it on there? It's just because it would clutter and everything. So if I go back 1, if I go negative 1, what is negative 1 squared? 1. So I go in the positive direction, 1. That's how you find the next point. That's just this equation here. In other words, a is 1. Okay, so if I were to go over 2, 2 squared is 4. So I go 1, 2, 3, 4. There's my next point. If I go back 2, negative 2 squared is 1, 2, 3, 4. If I go over 3, 3 squared is 9. So I go up 9. And negative 3, I go back 3, I go up 9. Does that make sense? That's essentially how you plot a parabola. So always refer it from the vertex, and depends on how many you go over and up. Okay, so that's how you draw a basic parabola. Now we're going to talk about our A. So we're using this letter now, A. If A is positive, it opens upwards. Okay, so opens up. So in other words, exactly what we have here. Opens upward. And in this case, our regular one, if you notice, since there's no number there, it's just positive 1. That's the number we're dealing with. If A is negative, our parabola opens down. Okay? So in other words, the exact same parabola, I'm going to deal with y equals negative x squared. So it's just negative 1. My vertex is still at the same point. I go over 1, down 1. Over 1, down 1. Over 2, down 1. 4. 4. Over 3, down 9. Over 3, down 9. So our parabola is a mirror image. The only problem is, the only difference is this is a negative one. So if it's negative, parabola opens downwards. Positive, parabola opens upwards. That one's pretty straightforward with A. The tough part about A is now that you know of negative and positive, now we're going to talk about just the units. If A is greater than 1, it stretches by a factor of A, it's called. So stretch, TCH, is that right? No. CH. That's not right either.
There's a T before the C.
Hold on.
Yes.
How can I spell stretch? That doesn't look right.
There's no C there.
Isn't that what I put the first place?
Yeah.
Oh, that's why it looks so weird. Oh my gosh. Thank goodness I don't teach you spelling, right? No, that's not right.
Okay, it's right here.
You're having such a mental.
Yeah.
Oh, I'm having a serious mental right now.
It was R-E.
R-E-T-C-H.
Yeah. That looks weird too.
It's really. Okay.
It's right.
By a factor of A. That's what's important right now. And the other option is if A is between 0 and 1, it is compressed by a factor of A. Okay. So in other words, what that means is we have our normal parabola. Quickly going to get it up here. Over 1, up 1, over 2, up 4.
Is this one if it's negative?
No, that's if it's like a fraction. So a quarter, a half, or 0.25, something like that. So again, here's our normal parabola. Remember, negative just means it opens downwards. Okay, so our normal parabola is y equals x squared. How about we do y equals 2, x squared. So in this case, a is 2. So in order to draw this parabola, the best way I can explain it is when you go over 1, what do we normally go up by? 1 squared, right? 1 squared is 1. So we go over 1, up 1. Whatever you go up by, you need to multiply by that a now. Yeah, you need to multiply. It's a factor of. So they're saying by a factor of a. So in other words, remember we go over 1, and then 1 squared is 1. Now I got to multiply that answer by 2. So I go over 1, I go up 2. Over 1, up 2. Same idea as if I go the other way. I go back 1, so negative 1. Now I got to figure out how far to go up. I square it, and then I multiply by my a. Whatever my a is, I multiply by.
So
by 2. Again, exactly. So I go negative 1 squared is 1 times 2 is 2. So I go back 1, up 2. Okay. Now if I go over 2, I square it to figure out how high I go. So I'm squaring it, I get what number? 4. And then I got to multiply by my a. So 4 times 2 is 8. So I go over 2, up 8. Over 2, 1, 2, 3, 4, 5, 6, 7, 8. Same idea as if I go backwards. The parabola is always going to be a mirror image right down there. So if I go back 2, I technically go up 8. So if you notice this parabola is thinner, I'm not very good at drawing on this. It's thinner, it's stretched. That means it's being pulled. Think of it as it's being pulled. So it's thinner than the original parabola. So it's being stretched by a factor of a. If it was by 3, it'd be even much thinner. If it was by 10, it'd be very, very thin parabola compared to our original one. Does that make sense? So normally we go over 1, up 1. This time you go over 1 and up by a factor of whatever a is. Technically we do that in the normal one, but the normal one a is 1, right? So if I go over 1, up 1, 1, and then I go up 1 squared, which is 1, and then I multiply by 1, I still get 1. It makes no difference. Our a is 1 in our original. Whenever a is different, you have to multiply by that number. So our other idea here, another one we could use is y, let's say a quarter. Okay, it's going to be a tough one to work with. But I go over 1, same idea, keep saying the same things over 1. Normally we go up 1, right? 1 squared is 1. So instead of going up 1, I have to multiply that by a quarter. So how much do I go up? A quarter. I only go up a quarter. So I go over 1 and a quarter is really small, something like that. Same idea on the way back. A quarter is really small. Okay. Let's think about 2. Normally I go over 2, up 1, 2, 3, 4. 2 squared is 4. 4 times a quarter is a whole, just 1. So I go over 2, up 1. Over 2, up 1. Okay? Let's try 3. Normally I go over 3, and 3 squared is 9. So I would go up 9. I multiply that by a quarter. I'm going to get 9 over 4, which is 2 and a quarter. So I go up 2 and a quarter, or 2.25. So I go over 3, up 1, 2, something like that. The whole idea here is if we follow this pattern, we're going to get something looking like this.
Do you think you're going to draw it?
Yeah, you'll have to draw it. So she'll want you to know how to draw it. So A is the hardest. When you're dealing with A, when you have to multiply by a factor of something, that's the hardest one to deal with.